the web page you should always go to for information about what's coming up in the next class. There is an OWL site for the course, and that's where you'll submit your assignments. But all of the other information is going to be here, because I hate OWL, it's terrible. So I try not to use it as much as possible. So today I thought what I'd do is start by giving a kind of a high-level introduction to the course and what the goals are from my point of view, how the course is going to be organized, and how you should sort of structure your time from week to week. And we'll start in a little bit today on how to generate graphics in R and how to plot data. So we'll do a little bit of that lecture today together, and then the stuff we don't get to because of time, you can look at on your own. So one feature of this course is all the slides that I'm going to present in class are going to be available on the web. And so you can follow along in class if you want. You can also look at them at home. Let me show you a little trick, because someone asked me already. So they're in HTML format, so you can use your arrow keys to go back and forth. If you press the question mark key, you get this menu where you can do a whole bunch of stuff, including a PDF export mode. So if you then press E, it does a bunch of stuff, and it looks the same, but now it's actually printable. So if you now, in your web browser, go to try to print that, you can select Save as PDF, and then it'll save this as a PDF file, where you can keep it on your computer in your own directory. You can write notes on it, you can print it out, and so forth. Okay, so if you want to save these as a PDF, I'll just go through those steps again. You press E to export it to PDF. You then print from your web browser, and you save it as a PDF. Any questions about that? No? Okay, good. Okay. Well, let's just go through these slides then. So, I already told you my name or what course this is. I'm a professor in psychology, and I'm also joint appointed in physiology pharmacology, and my area of research is human motor control and motor learning. So that's what I do. If you're interested in that, you can check out our lab website where we have more information about that topic. And the most important thing about me as an instructor in this course, I think, is I don't hate statistics. And I didn't put it here, but I did used to hate statistics when I was in your shoes. When I was an undergrad at Queen's, way back when, I took a course like this, although there was no R or RStudio. And we learned about t-tests and analysis of variance and all that stuff. And we had to do everything by hand. We had an exam where we had to calculate this giant ANOVA by hand and do all this crazy stuff. And I hated it. And most people hated it. Because it just seemed like you were memorizing these weird, arbitrary facts without really understanding why. And for me, it took several stats courses before things finally started to click. And I could kind of understand, oh, I see. This is kind of like that. And that's why we do this. So I guess what I'm trying to say is, if you feel like you hate statistics already, that's okay. So did I. It doesn't necessarily mean you will continue to feel that way as you do more of it. And I hope by the end of the course, fewer of you hate statistics. If you have any questions, just raise your hand. Lectures are once a week here. You've already done that. Your lab and tutorials are also once a week. The class is divided into 8 different lab sections, and so each of you are in a particular lab section. You should be able to know what that is on the Student Center. On the OWL site, on the main page, is a list of each lab and where it is, what time it is, and who your TA is. The TAs are going to lead those labs. And I already told you where all the course information is to be found. Here's how the grades in the course will work. There's a homework assignment assignment every week. And there's 10 of them, and they're worth 2% each. So homeworks together will be worth 20% of the course grade. And then there's a midterm exam worth 40, and a final exam worth 40. So fairly simple. The homeworks are not worth as much for a couple of reasons. First, I didn't want you to be fretting and worrying from week to week about what your homework grade was. Because I want the main goal of these homeworks to be for you to learn how to do stuff. And the grades are kind of a byproduct. The main place where you're going to be tested and assigned grades is going to be the exams. Because that's going to be where you're going to be tested on your knowledge of the concepts. In the lab and tutorials, it's mostly going to be about using R and RStudio to actually do stuff. And on the exams, I won't be asking you to write any R code or anything like that. It's all going to be conceptual. The midterm exam will be in regular class time here on February 28th. And the final exam, we don't know where it is yet. There's no there's no textbook you have to buy in this course. We're going to be using free books and resources that are on the internet. And there's lots of them. And for each week, I'll post what the assigned readings are. These are the two main books we're going to use for learning about R and graphics in R. They're both free and they're both on the web. R for Data Science is a really great book. It's focused not on statistics, but it's on what's called data science. So how to load in and manipulate data and plot data in various different ways. And we're going to use that in this course. And this is a book exclusively dedicated to graphics in R. And we're not going to use all of it because it's a big book, but we're going to pick parts of it that are relevant for us. But these are good things to just keep in your toolbox for future reference. They'll be useful to you as you go on, even after this course. Here's another statistics book that is out there, freely available on the web, that we're going to use in this course. And all the links are on the course website. But these are links as well. If you click that, it'll go to that book. And this is yet another book that's now focused on statistics itself using R. And it's also free on the web. So you should bring your laptop to class so you can try things out as we look at them together. Whenever I put R code on the slides, you'll see in a second there's a little icon in the corner where you can click on it to copy that code, and then you can just go over to RStudio on your own machine and paste it, and it will paste it in there. So all the code you can try out as we go along. You're going to need to install these two things on your computer. You need to install R, which is the actual R statistics language. It's kind of like Python, but it's not Python, it's R. And then also install RStudio. And RStudio is, it's called an IDE, an integrated development environment. It basically provides one big window where you can enter R commands into a console, but also edit files, scripts in R, and also see graphics, and also see your file system. So we'll see how it's useful, and you'll use that in the labs. They're both free, and they're both available for Mac, for Windows, for Linux. So you should download and install those right away. So R is kind of like Python. That is a computer coding language. But unlike Python, which is a very general language, R is oriented particularly around data analysis and statistics. It's a language that was created by statisticians for statisticians. So it used to be a lot more difficult to use, but in recent years people have added various add-on packages that make it much easier to use. It's free, which means you don't have to pay money for it. It's also open source, by the way. If you want to go and look at the actual source code for R, which is written in another language called C, the letter C, you can actually look at the code for R itself, and you can, in principle, download the code and alter it and have your own custom version of R. So it's kind of cool. RStudio is not open source. You can't see the code, but it's still free. It doesn't cost money. And like I said, it's kind of like a big window where you can edit code, enter code, see graphics, and see your file system. So the way the course is organized is lectures are where I'm going to present kind of the high-level logic and rationale of the weekly topic and kind of guide you through a couple of the main concepts. I may or may not show examples of things in RStudio. And in general, you're going to get more out of each lecture if you do the readings in advance of the lecture. If you don't do the readings and you come to lecture and you absorb everything that we do in this room, you're only really going to have, I don't know what, between 60 and 80% of the stuff you're going to need for that week. The rest of the stuff is contained in the readings and in the labs that you attend with your TAs. So, in general, if you come to every lecture, absorb everything that happens in this room, pay perfect attention, but you don't do the other work, you could still probably get somewhere between 60 and 80% in the course. But really, to really do well, you have to do the readings as well and go to the labs and try to absorb that material as much as you can. The homework assignment each week is based on the topic we cover, and you're going to write code in RStudio to accomplish various tasks. What you should do to prepare for those labs is do the readings, try out the code in advance of the labs in the readings, of course attend lectures, and of course attend the labs. Now, about attending the labs, we'll get to that in a sec. The homework's going to do 5 o'clock each Friday. And on the following Monday at noon, a sample solution will be available in OWL. And so that's the deadline. If you hand it in after the deadline, then here's how it works. For each 24-hour period that your homework is late, until Monday at noon, you'll get a penalty of 0.5% out of 2. For each 24-hour period. So you can hand it in a day late, but you'll get 0.5 out of 2 docked. You can hand it in 2 days late, and you'll get 1 out of 2 docked. And if you hand it in after Monday at noon, you just get 0 because the sample solution is already up there. Of course, if there's some legitimate reason why your homework is not handed in or it's late, then you should go to academic counseling and get an accommodation. That's the way to do it. So each homework is kind of divided in half. There's a lab component, which you do together with the TA in the tutorial. So the TA's role is to kind of take you through each step in the lab component, show you how it works, answer questions about it, and then the homework kind of continues for the home component. And the home component is what you're supposed to do on your own after the lab. And it kind of builds on the lab component. Both the lab and the home component will be graded. So by doing the lab component with your TA, you're essentially automatically getting half correct on that homework. So it's really the last half that's up to you. I will say, as it says here, lab attendance is, in principle, optional. You don't have to come to labs. You can just do the homeworks on your own. I think that's actually probably feasible for many of you who are really gung-ho and do all the readings and attend every lecture and are really into the material. You could probably skip a lab and still do okay. But I wouldn't recommend it. I mean, the labs are there to help you. And so you should just go to the labs. If you don't attend the labs, then don't come to the TA afterwards or to me afterwards for help. Again, unless there was a legitimate reason why you have to miss the lab. The labs are there for you to get help with the assignments. So take advantage of them. I already said that. So let's talk about exams just quickly. The way they're going to be organized is there'll be some multiple choice questions, there'll be some short answers, and maybe some slightly longer short answers. And they're mainly going to be organized around interpreting data, visualizing data, and the logic of those things. The logic, meaning, and interpretation of stats tests, and how to interpret the results of those statistical procedures and the assumptions involved in them and how they work. I won't ask you to generate code on the exams. The homeworks are all about generating our code and doing stuff, but the exams are not going to be like that. The exams are going to be focused on the concepts. The exams, the midterm will be in class, like I said. And I already posted some sample questions for the midterm on the website. You don't have to memorize equations. I won't ask you to reproduce equations from memory. You might have to be familiar with equations, though. I might show you an equation on an exam question and ask you somehow about how it works, or what a particular term means, or what happens if that term goes up or goes down. So you should be familiar with any equations that we cover and how they work, but you don't have to memorize them. And there also won't be any calculation on the exams. I'm not going to ask you to calculate crazy long stuff. So you don't need calculators. The exams will be closed book, no laptop, no calculator. All you need to bring is a pencil or a pen and your brain, maybe a bottle of water. You can also bring one double-sided cheat sheet if you want. Standard letter-sized piece of paper. But it has to be handwritten, not typed. And no magnifying glasses. I will say, you could produce a cheat sheet that sort of in very tiny type has all the material that's on the slides and a lot of the material in the readings. You could probably do that, but it wouldn't help you much if you didn't already know the material, right? Because you'd have to look at each exam question and then sort of read the whole cheat sheet and try to figure out the answer. So, generating a cheat sheet, the actual act of generating one, is actually not a bad study aid, because it's a good way to summarize the main important concepts in the course. But don't go into the exam thinking the cheat sheet's gonna help you much. But you're allowed to bring one. There is a syllabus, an official course syllabus posted on the website as well, so do read through that. It contains all the details and procedures about various things. The main goals of this course are for us to understand the logic and rationale behind various statistical tests. So we're going to learn a whole set of tests building on the work you did last term. So where did you end up last term? You did t-tests. Did you do analysis of variance? You did a simple one-way analysis of variance? Okay. And did you do linear regression? You did? Okay. So we're going to cover linear regression also. So we'll do that as a review. And we're going to build that up to multiple regression. Did you do multiple regression at all? No. Okay. So we'll build up to that. And the common thread in this course is going to be linear models of data. We're going to see, in fact, by the end of the course, how everything we do, from linear regression to multiple regression to analysis of variance to analysis of covariance, it's all actually just a linear model of data, which is kind of cool. And we're going to use RStudio for all of this. So last term you did Python, right? In 2011. How did, just a quick show of hands, how many people sort of like Python? And how many people don't like Python? Okay. Of the people that don't like Python, do you like something different, or you just don't like code? Does anyone have any other non-Python experience? Yeah? What do you have? Java. Okay. Anyone else? Yeah? Java. MATLAB, yeah. So, I mean, R is a little bit like, I mean, R, Python, MATLAB, Java, in a sense, they're all the same kind of thing. They're all a procedural programming language. But like I said, R is focused on statistics, and so it's easier and faster to do cool things in R, I think, than it is in Python. So, a little pep talk. Stats does have a bad reputation, and I think that's in part because often the way courses are taught, they're stressful and boring. They involve a lot of math and memorization and tiny little details. And it's often focused on just rote memorization of recipes without really understanding why. And so we're going to try to counter that in this course and focus on the logic and rationale and the why. And that's the goal, is that you end up with a little bit more understanding about how things work and why. I've talked about that already. So what is statistics? It's not math, although it makes use of some math. It's not just calculation, although we do perform some calculations. And it's not only just different ways of describing data. If you ask a sort of a layperson out there, maybe your parents or your grandparents or someone else, they ask, what are you taking? You say statistics. Most people think of statistics as a descriptive way of talking about numbers. And that's part of it. But really what I want to focus on here in this course is that statistics is a logical framework for interpreting data and making decisions about data. And it helps you answer the question, what do my data mean? And an important concept, I think, is that we're not usually interested in our data set on its own. Usually we're interested in what our data set says about the world. You know, in science, we're not interested. If I do an experiment and you're all in my experiment, the point of my experiment usually isn't just to answer a question about you specifically. It's to answer a question about how does motor control in humans work. And you happen to be humans, and I can't measure everyone on the globe, so I have to take a sample. And so we use inferential statistics to make conclusions about how the world works based on the smaller samples that we're able to analyze. So stats is really a logical framework for doing that. Here's some elements of that framework. You probably already took a little bit of probability theory in your previous courses, a little bit. And sampling, the idea of a sampling distribution of means, does that ring a bell? Yeah. Null hypothesis and significance testing, you've covered that a little bit already in 2011. That's, like how a t-test works and you get a p-value. In this course, we're going to talk about linear models of data. Another element in statistics is you have to have some competence in some tools to actually do these kinds of things. And like I said, in the old days, it was paper and pencil or calculators. When I took a stats course, it's like, this is one of those stories. When I had to walk to school, uphill both ways in the snow. But when I took the equivalent of this course in undergrad, in the previous century, I didn't have a computer at home. No one had a laptop. Laptops didn't really exist, not really. So you kind of had to do things by hand with a calculator or go to the computer lab on campus and type weird commands into a big mainframe computer. It was terrible. So nowadays we're lucky. We have these really cool, readily available tools, software tools, and we have laptops that are, well, some are expensive, some are less expensive, but you don't need an expensive laptop to do what we're going to do. In future courses, you might learn about Bayesian approaches, which are a little bit different than null hypothesis significance testing. In this course, we're going to use linear models of data to describe various phenomena. We're going to use null hypothesis significance testing for making inferences about the world based on our data. And we're going to use RStudio as the tool. course webpage. Good. Any questions about what I covered so far? So that was the welcome slides. There are some introductory readings I posted, and there's some videos about how RStudio works that you can go through. In the homeworks, we're going to use these things called R Markdown files. Oh, question? Yes, so labs for this week are on from today forward. Was your lab on Tuesday?
Yeah.
So I don't think I think that lab happens next week. Does that make sense? Yeah, it's kind of confusing. One of the labs is actually on a Tuesday and the lecture is on a Wednesday and then all the other labs thereafter. So the homeworks are not due this Friday. The first homework is due next Friday. So you will have a lab on Tuesday and then your homework will be due on Friday. Does that make sense? Yeah. Other questions? Yes.
So for those of us who have a lab on Friday, having the assignment that corresponds to that, would you do the following week?
Yes. So the assignment is due at the same time for everyone. So if your lab's on Friday, then it's the following Friday that your assignment is.
We won't be learning about the information for the assignment right before the...
No. Yeah, so everyone will have a lab this week, and some of you will have a lab on Tuesday. And the first assignment is due not this Friday, but next Friday. Yeah. Good. What else? There's a homework 0. I called it homework 0 because it's not worth any grades. You should go through it and submit it to OWL and you get a check mark. It's just for practicing using our RStudio and generating an R Markdown file and uploading it to OWL. So it's a non-stressful exercise just in the mechanics of the course. But there is homework 1, which is due January 19th. So not this Friday, but next Friday. All right. Any questions? Other questions about the course mechanics before we start looking at plotting graphics? Just a quick show of hands. Who has RStudio and R installed already? Good. Who doesn't? Okay. If those of you who don't, you could try doing it now. I'm not sure how fast the Wi-Fi in this room is. But it's not strictly necessary. Like I said, all the code here you can copy and paste at home afterwards. All right, well, let's go into the first topic then. The first topic is going to be data wrangling and visualization 1 using ggplot2. So ggplot2 is an add-on package in R, which you can install, and I'll show you how. And it provides a set of really cool commands to generate really good-looking graphics really easily. We'll look at that today, and then next week we'll look at a different package called dflyer, which is an add-on package that lets you manipulate data. Sort data, select data, filter data, reorder data, that sort of thing. And then in the third week, we'll actually start looking at statistics. And we'll start with a review of linear regression.